We're going to run, going to run through the electron cloud session. I have put the answers on here already, and I've taken the liberty of writing down the diagonal rule. If you want to know the real reason I did that, this is the second time I've made this video. I made too many failures to change screens in the others. But here we go. So this is the diagonal rule. The electron order, filling order is like this. And so we know this is a correct answer because this one is the one that follows this order. So it goes 1s, and then 2s, then 2p, then 3s, then 3p, then 4s. The others get out of line somewhere, like 4s, 4p, they don't follow. There's a mistake in all the others, but B is correct. Now on this one, you're starting in the middle, and they either start with 4p or 5s. You know this one can't be right because there's no 5s is not followed by 6s. 5s is followed by 4d. So you find the one that's correct. So 4p, 5s, 4d. So you might want to remember how to write the diagonal rule down, but it's a pretty straightforward rule. Looks confusing, but 1s, 2s, 2p, 3s, 3p, 3d. Just 1, 2, 3, 4, 5, and every time you add another sublevel. Okay, which one of these is not valid? Well, there's no such thing as a 2d. See, empty spot there. Orbitals are places in space. We call them a region in space. And the electrons, of course, are in the orbitals. So the answer to that was B. And a D sublevel, remember the number of electrons you can have in each one of these sublevels, the number of beds or the number of orbitals, was for the S sublevel was 1, and for the P was 3, and then 5, and then 7. But for the number of electrons, or the number of people, 2, 6, 10, 14 is twice whatever the beds are, because each bed could hold 2 people. Okay, so the maximum number of the D sublevel was 10. That's why the answer was E. All right, the maximum number of electrons in the S sublevel, that was 2. There you go. And if they occupy the same orbital, remember they had to be spinning in opposite directions. That was B. And then in the orbital diagram for oxygen, how many unpaired? So I drew this out. Remember when you're drawing, I'll redraw this in red here. So the way I put them in was up, down, that was 2, up, down, that was 4. And the oxygen has 8 electrons. I was going to show you that real quick. So that was 4, then 5, 6, 7. And at that point was when I had to pair up. So you don't pair up till the end. So how many unpaired are there? That one and that one. So there's 2 of them that are unpaired. All right, energy levels in the second energy, sublevels in the second energy level, there was an S and there was a P. So S and P only. Orbitals in any D sublevel, orbitals, that was the number of beds, so that'd be 5. When there's an option, will electrons pair up or go one at a time? Well, we just said that they go one at a time before they pair up. And then how many electrons in the valence outer shell of neon? So to do that, we'll take a quick look over here at our periodic table. This was the blank periodic table you guys had to do. So you got 1, 2, remember all these columns 1, all these 2, all these short rows down here were 2, then 3, 4, 5, 6, 7, and 8. So neon is in this position right here. See neon right there? That position right there. So the answer to that question is 8. It's in that 8th column. Okay. Now, the next question, I wrote out this configuration. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. I'm just going through the diagonal rule. It ends in 6p3. The highest coefficient is the 6. So that's one way to know that. Write it all out. But another way to know it is to look at the periodic table and notice that bismuth is in the 6th period. And so all of these, their highest coefficient will be 6. For all of these, their highest coefficient is 5. For all of these, their outer shell is 4. Notice how I changed from highest coefficient to outer shell. They mean the same thing. So the highest coefficient here is 3. That's the outer shell, the 3rd energy level. These guys down here, the 7th energy level would be the outer shell. All right. Now, when you form a compound or transfer electrons, what subatomic particles are transferred, that'd be the electrons, because the electrons are on the outside. All right, so now, looking at the periodic table, there are blocks on this periodic table. You can see this is the p area over here. Quick, how many electrons in a p sublevel? There are 3 beds, 6 people. So 1, 2, 3, 4, 5, 6. How many beds were in the d sublevel? There were 5, right? But each bed holds 2 people, so that I would expect this part of the periodic table, which is marked as D, hang on. There it is. This part right here that's marked as D, see them right there? That would be the D block, and it's 10 wide. This part here is going to be 2 wide. That's the S region, and that's the F region. All right, so then if we go back and look at the one that contains bismuth, bismuth you see is right here. That's in the P region. So that's why I say A down here for bismuth in the P block. So is aluminum. You could have put either answer. So the P block is aluminum. And on the potassium, aluminum's right here, P block. Potassium's over here, that's in the S block. So it contains potassium, S block. It contains samarium. So you go over here, samarium, Sm, is down here. And that's in the F block. So that's the F block. And I didn't have anything that was listed in the D block. None of these elements are in the D block, so the D block would be E, none of those. Okay, in order of increasing energy means from low to high. And so what I did was I went through the diagonal rule. And the first one of these listed to show up was a 2s. So I listed that as number 1. After 2s came 2p, but it wasn't listed. I didn't have another one, 2p, 3s, 3p, 4s, 3d. None of those were listed until I got to 3d. So that was the second of these. This is the second lowest energy. And I just went through it like that, going from low to high. So the highest, our last one is 6d. See, that's the last one you come to up here. 6d. And then one right before that was 5f. And then 5f right there. That was right before 6d. So you're just going through the diagonal rule, putting them in order of increasing energy. That's the answers list right there. All right, now we're going to do the complete configuration for phosphorus. I'm going to go ahead and finish it up on this video. So the complete configuration for phosphorus, we need to know how many electrons phosphorus has. And we also need the diagonal rule. So I'm just going to detach it. Lay it down right there. All right, so phosphorus has 15 electrons. So here's my diagonal rule. So the first thing to fill in for phosphorus for any atom is 1s, and a 1s holds 2 electrons. Then 2s holds 2 electrons. Then 2p holds 6 electrons. Then 3s holds 2 electrons. And then 3p could hold 6, but phosphorus only had 15 electrons, remember? So 2 plus 2 plus 6 is 10, plus 2 is 12, so I need 3 more there. Okay? So how many electrons in the outer shell of phosphorus? The outer shell is the highest coefficient. So the number of electrons, 2 here, 3 there, 5. So you can do it that way. Oh, shoot. I don't know why my camera went off. All right, so this was the electron configuration. So 3s2, 3p3. There's 2 here, there's 3 there, so there are 5 in the outer shell. Another way to know how many is in the outer shell, look at phosphorus. This is the look at our columns. This is column number 1, column number 2. Skip the short columns. Column number 3, column 4, column 5. Phosphorus has 5 in the outer shell. It's in the 5th column. All right, the orbital diagram for tin, you can use circles or draw boxes. So here we go. Tin has 50 electrons. So we're going to use the diagonal rule and think about the number of orbitals. So for the s sublevel, 1s you'd have 2 electrons. And the 2s has 1 orbital, 2 electrons. After the 2s is the 2p. It has 3 orbitals. I'm up to 10 electrons. After 2p comes 3s, has 1 orbital, 12 electrons. After 3s comes 3p. After 3p comes 4s. After 4s comes 3d. 3d had 5 beds in it. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right now I'm up to 30. I'm going to 50. There were 50 electrons, so I'm going to move over here because I ran out of room. So that's 4s. After 3d would be, oh, 4p would be next. I messed up. After 4p is 5s. And then after 5s is 4d. I'm getting close. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 30, 32, 34, 36, 38, 40, 38, 40, 42, 44, 46, 48. And we want to go to 50, so that'd be 5p, like that. And there you go. That's your orbital diagram for 10. And I said use circles. You could have done it like this: 1s, 2s, 2p. It's another way to do it. Okay, how many electrons are in the outer shell of 10? This was 10. Fifth energy level. How many are there? 2 here, 2 there, 4. Okay, which element is this? Okay, this is about the orbital notation. Okay, so we have krypton, had 36 electrons. So this symbol right here is 36. Add 2. This symbol right here is 36. Add 2, add 10, add 5. So 36 and 2 is 38. 38 and 10 is 48. 48 and 5 is 53. So that's element number 53. So what element is it? It's iodine. So that's I. Okay. And for this question, I haven't really taught you this as well as I need to, I don't think, so we're going to skip this question. But just in case you're wondering, the valence shell only is like this. So you got P, as phosphorus has 5 valence electrons. So you can see right here, phosphorus is in the 5th column, 3, 4, 5, 5th column. This Roman numeral tells you that too. 2 electrons are shown here. That's the S sublevel. And you have 1. So if you're doing an orbital diagram, the S sublevel would hold 2. The P sublevel would have 3. They'd be all by themselves. So these 2 go here. These 3 here. It's just another way to write it. Gallium, is this element right? Oh, darn. Sorry about that. I forgot to change over. So let's start that again. So phosphorus has 5 valence electrons. So 2 go here, then 3 go here. So 2 here, and then 3 here, 2 here, 3 here. So these 3 go there, these 2 go there. Gallium has 3 valence electrons. It's right here. So you just write the symbol down and put the first 2, so the arrows would look like this for the outer shell. And these 2 go here, and that one goes by itself. All right, and this next question says, how many electrons are in all of the P sublevels of 10? So I'll write them in red. We'd have 6 here, 6 here, 6 there, 2 there. So what's that answer? 20. So once again, 6, and the 3p there's 6, and the 4p there's 6, and the 5p there's only 2. So add 6, 6, 6, and 2, and you get 20. And that's it.